From Astro to Geo, explore the universe with a physics degree. Physics is known as a fundamental science, as it involves a true understanding of how the world really works. Today, we're going to talk about the different degrees available within the Department of Physics at the University of Alberta. Our geophysics program is ranked number 4 in Canada and in the top 100 in the world, with general physics and astrophysics ranked in the top 10 in Canada. You will get to work alongside world-renowned atomic physicists who have created never-before-seen nanotechnology, professors who have explored Antarctica to investigate geophysical properties that control earthquakes, and researchers developing new tools to translate data from quantum computers to quantum communication channels such as fiber optics. This international recognition for advancements in physics keeps Alberta on the map in terms of future technologies and diversifying Alberta's economy. Not only are they top in their field, but professors have been awarded various teaching awards for their dedication to inspiring the next generation of physicists. Students are encouraged to take advantage of our unique learning sites, including the Astronomical Observatory with its 3 high-powered telescopes. We also have Canada's largest university-based meteorite collection with over 1,800 specimens from all over the world. Meteorites reveal much about the Earth's origins and the conditions that existed during the formation of the solar system, making this collection a tremendously valuable scientific teaching and research resource. If you're curious about what these spaces look like, we encourage you to check out uab.ca/sci-tours for virtual tours. Students can drop into the open access makerspace called The Shack, with equipment ranging from a Volterra circuit board printer, laser cutters, multi-material 3D printer, and other manufacturing equipment. You can leverage the theory you learn in class with your creative skills to bring your ideas to life. What kind of projects are we making? Well, The Shack is attempting to build a cosmic watch, which is an open source cosmic ray detecting device that was developed at MIT. Our aim is to recreate the device and fit it with upgrades. The Shack also has a decommissioned 2.5-ton Tesla magnet installation for demos and display. As a research-intensive university, we want you to get involved in research. Examples of recent undergraduate research projects include creating an algorithm for searching for evidence of black holes and highly excited string states, investigating the electrical properties of microplastics and why they're attracted to clay and sink in areas where rivers meet the ocean, measuring stellar feedback in nearby galaxies with James Webb Telescope data, using ultrasound imaging and machine learning to study bone tissues, using molecular biophysics techniques to measure the mechanical properties of coronavirus RNA structures, and using geophysical techniques to conduct hazard assessments at carbon capture sites. uab.ca/URI is a great resource for students to get involved in research, and there are even opportunities for high school student summer research. Joining student groups such as the Undergraduate Astronomy Society, Alberta SAT, or UAlberta Space Robotics Club is an excellent way to connect with fellow physics students to work on interdisciplinary projects, whether they are just for fun or for prestigious international competitions. In 2017, a student team designed, built, and launched the very first Made in Alberta satellite, Exalta-1. More recently, a U of A student team outperformed many other universities and was selected by NASA to have their project launched into space. The Pepper X project was almost entirely built, manufactured, and tested by U of A physics and engineering students. And the purpose of the experiment was to look at how energetic particles in space interact with the Earth and to investigate the impact this interaction can have on climate. If pen and paper equations are more your thing, top physics students are often invited to write the National Canadian Association of Physicists, or CAP, University Prize examination. Passionate students are also chosen as delegates to attend national conferences, such as the Canadian Conference for Undergraduate Women in Physics. This event offers a unique opportunity for female-identifying students to connect with others who might also feel like they are outsiders to the physics community, and give space for them to openly discuss their struggles and their joys in working in and studying in physics. Now let's talk about programs, which range from being broad and flexible to structured and specialized. A major degree is our most flexible degree program, where approximately half of your courses are in one main subject area and the rest can be elective courses. Most students add an optional minor, which then allows you to design your degree around two areas of interest, plus still have lots of room to add elective courses from almost any subject. An honors degree is for students who are passionate about and fully committed to their area of study. Topics are studied in depth, and the biggest difference between major and honors is that there is an added senior research project, which is taken during the final year. These students are expected to maintain higher grades than those in the major program. Both of these degree types are 4 years in length if taking a full course load, but can be taken part-time. We also offer a 5-year Bachelor of Science, Bachelor of Education combined program, allowing you to graduate with 2 degrees if you're interested in becoming a secondary school physics teacher. So areas of study in major and honors include general physics, astrophysics, mathematical physics, and geophysics. Although we do not have an official undergraduate program in biophysics at this time, students do have access to courses in these topics and have the opportunity to work with professors on research projects in this area. Physics is offered as a Bachelor of Science major or honors program, or can be taken as a minor. The programs are designed to build a strong background in modern physics, studying the universal laws governing matter, space, energy, and time, and the interaction between these elements. Course topics can include mechanics, thermodynamics, electromagnetism, relativity, or quantum mechanics, and many more topics which would also include laboratory work. Consider adding a minor to a physics degree from another subject area for a broader understanding of the world around us. For example, a physics major with a minor in ancient and medieval history would allow you to accurately digitally recreate the swings of battle axes from historical fights based on documented injury patterns and the type of material those weapons would have been made from at the time. For students who want to focus on a specific area within physics, we offer more specialized programs, such as the Bachelor of Science in Astrophysics. Astrophysics can be taken as a major, minor, or honor subject. You can explore a wide range of open questions about the physics and properties of stars, galaxies, and the universe. Astrophysicists probe how stars and stellar systems evolve, the properties of and the physics behind the most extreme astrophysical objects, like neutron stars, black holes, and quasars, and the physics and structure of the universe on cosmological scales. Course topics include galactic and extragalactic astrophysics, upper atmosphere and space physics, special and general relativity, and quantum mechanics. An Astro 101 is offered as a massive open online course that can be taken online at your own pace for credit once you're part of the program. Bachelor of Science in Mathematical Physics. Mathematics is an essential tool for physics. It's the language that we use to formulate physical problems. From calculus to algebra, geometry to group theory, mathematics is fundamental to theoretical and experimental physics. Not only are mathematical structures often developed for the needs of physics, but modern theoretical physics has also been the origin of profound new developments in pure mathematics itself. In the mathematical physics program, you will cover topics such as how to describe and analyze physical systems mathematically, classical mechanics, quantum mechanics, thermodynamics, and relativity. And graduates of the mathematical physics program are well suited to postgraduate studies in mathematics, applied mathematics, physics, and engineering. Many establish careers in research, taking up academic positions in universities, colleges, and research institutes. Pictured here is a physics professor whose research focuses on the unusual geometry of hyperbolic crystal lattices that can be fabricated in the laboratory. His team is creating a framework to describe the motion of electrons through these lattices and how this can be used in real-world applications such as computer chip technology and quantum computing. The Bachelor of Science in Geophysics is offered as a major or honors program, or as an optional minor subject, and includes a field school in your last year. A recent graduate said that when she told people her major, they would ask, "What even is geophysics? Do you study how fast rocks can be thrown?" Well, our geophysics program uses principles from physics to understand the structure and dynamics of the Earth below its surface. By understanding the Earth's core, this data can be used to assess natural hazards or locate energy sources, mineral and petroleum deposits, artifacts, and more. Geophysics course topics can include hydrogeology, seismology, borehole methods, and survey techniques to help students answer important questions like why do the Earth and planets have magnetic fields? Or can we forecast volcanic eruptions and earthquakes? Does hydraulic fracking cause earthquakes? And is geothermal energy an option for Canada? The student I mentioned said that her program prepared her for a unique opportunity to spend 2 months off the grid traversing the Juneau ice field to study components of the glacier environment. Fun fact, she was awarded a ton of scholarships because she was the only fourth-year student in the program at the time, so had no other students to compete with. The honors program is professionally accredited by the Association of Professional Engineers and Geoscientists of Alberta, allowing graduates to readily obtain their professional geophysics designation. What is a geophysicist? Well, some geophysicists study the Earth's gravitational and magnetic fields. Others study how earthquake waves or radio waves travel through the Earth. Geophysicists work in many areas, including exploration of oil, gas, and minerals, monitoring underground contamination in groundwater, or reducing hazards from volcanoes and earthquakes. So yes, geophysics is much more than studying how fast rocks can be thrown. And lastly, if you're thinking about becoming a secondary school physics teacher, you can consider our combined program that allows for completion of 2 degrees, a Bachelor of Science and a Bachelor of Education in 5 years of study. Your first 2 years in the program are spent in the Faculty of Science, and the remaining years are with the Faculty of Education. Students choose from a combination of majors and minors in physical sciences, biological sciences, or mathematics, and follow a structured full-time course curriculum. Graduates of this combined degree will be certified to teach all subjects in grades K to 12 within Alberta curriculum schools. However, the program is specialized for teaching science in grades 7 to 12. Science internship opportunities integrate university studies with relevant paid work experiences. Placements can be between 4, 8, 12, or 16 months. We host resume and cover letter workshops to help assist in connecting students with companies for work term periods. And students are actually more motivated and focused to complete their remaining courses after gaining insights into the professional world through an internship. An internship can add time to your degree, but there are major benefits, so it's an ideal way to start building a professional network and figure out what you want to do with your degree while still in school. A recent physics internship was at the Canadian Snow Lab in Ontario, working on the operation and analysis of data from the high-purity germanium detectors and other dark matter detectors. Located 2 kilometers underground, this is one of the deepest underground labs in the world, which provides excellent shielding from cosmic radiation. What can I do with my degree? Not all physics-related jobs require you to have a master's or a PhD degree, but some will. Some examples of careers include diagnostic imaging physicist, environmental auditor, exploration geophysicist, game design physicist, laser spectroscopy specialist, satellite development, atmospheric scientist, and more. You can also visit uab.ca/science careers to see a longer list, as well as some companies that students have worked with during internship placements. Let's talk about admissions. Admission to the Faculty of Science is assessed on your marks from 5 core high school subjects. All science programs require English 30-1, Math 30-1, 2 grade 12 science courses, plus 1 other course. I've underlined Physics 30 because although you can technically be admitted to physics using 2 other science courses, you will need Physics 30 in order to register in your first-year physics classes. Math 31 Calculus is also recommended, and so is Chemistry 30 if you're going into the Geophysics program. You can visit uab.ca/programs for a list of specific courses that fall under that final course category of fine arts, humanities, and languages other than English. For students taking certain AP courses, and receive a grade of 4 or higher on the final exam, we can grant transfer credit for an introductory physics class, meaning you won't need to take that class again in your degree. This also applies for IB students who receive a grade of 6 or higher on certain courses. And more information can be found at uab.ca/AP and uab.ca/IB. If you have any questions about our Faculty of Science programs, please feel free to contact our student recruitment team at science.recruiting@ualberta.ca. We look forward to seeing you at the U of A.